So, good evening. So I'm Caroline Landry. I'm working in the DevOps team in INRIA in Rennes, in Brittany. And I joined INRIA 2 years and a half ago for leading the STAMP project. And before that, I worked something like 30 years in the industry, making development, software development and tests. So STAMP, what is STAMP? STAMP is a European project, including 5 companies, 4 research institutions, and 1 open source consortium, OW2. And STAMP is about DevOps, so we saw it's something like we already saw today. And the basic idea was DevOps is actually about automation and continuous testing, in the sense of at every step you need some validation and acceptance of the step before going to the other one. And that includes also a lot of technologies that you can use at every step, different step, depending on where you are. So it includes unit tests, so you can have some linters or that are already when you are developing that allow you to avoid some compiling errors, it's kind of things. And of course, it's linked to the continuous integration and continuous development. And so one of the key points now for the test, automated test, is that the test suite are more and more complex. And there are now a lot of software that have more line of code of tests than the application itself. So it's actually, we make some measurement of some open source code, and it's at least third of the projects here have more line of code of tests than software. So the second idea, main idea of STAMPs was the concept of amplification. So the idea there is really the knowledge of what you need to test. It's a skill of the developers, so human developers. And so the developers know what they expect from the test and what the results they want to have. But the thing is, since they are human, most of the time the tests are incomplete. And so the idea is to take the test and to amplify them. So it's generate from this test suite new test or new assertion, complete the existing test or generate new tests from there. So the focus of STAMP, so we need to focus on some research on DevOps, because there is really a huge, area to complete. And so first thing is unit testing. So we will see test amplification and how to test your test, actually. Second one is configuration testing. So we already heard of it. So it's about tools about Docker files and manipulating Docker files to automatically generate the configurations and execute your test suite in the different configurations. And the last thing is when you operate your software and it is deployed, you also have need some tools to monitor or to help you to give feedback to the developers when you have some crashes or some problem on the software. So I will present you here more the unit testing part, since it's the research leads by INRIA and KTH. And so the first thing is a tool named Descartes. And the object of Descartes is to test your test, actually. So we saw that the test now is more and more complicated. It's a software itself. And so what about testing your test? Writing another software to test it, like Vashkiri, and writing another software to test and run again. So we need to find something else to validate your test. And so one of the one of the techniques that appears a long time ago, it's mutation analysis that allow you to introduce fault in the code and to check that if your test suite detects this mutation. And something like 2 years ago, there was it's 3 years ago now, there was a new concept about mutation analysis that is called extreme mutation. So instead of working of the instruction level, so because standard mutation analysis allow you to change, for example, equal into not equal, plus into minus, these kind of things. And for extreme mutation, you actually remove the entire body of a method and replace it either by nothing, if it's void or return void, or by a constant value. So, and it's Descartes, so it's an implementation of this extreme mutation analysis, and it's based on PIT, that is a tool available for 10 years, an open source tool available for 10 years for mutation analysis, where you can substitute and replace all the mutation engine. And it allows you to compute the code coverage, so standard code coverage you can have, and so a mutation score that is a ratio between the number of mutations that are not detected towards the number of generated mutants. So it allows you to find what we call the pseudo-tested method. Pseudo-tested method is a method that is not detected by any test. So you can remove the whole body of the method and the test suite is still green. And so it allows you to find weaknesses in your test and weaknesses in your code, actually. So, as I say, pseudo-tested method is a method executed by the test suite, but where any mutant can find the mutation. And surprisingly, we have found pseudo-tested method in every project we test. So a pseudo-tested method, for example, if you took this example from Apache Common Collections, it's singletons, and we have this add method that has an associated test, and the purpose of the test is really to test if the exception is raised. And you can remove the body of adds. And so what happens here is that if you remove the body, the exception is not raised. So the test suite is still green. So we call that a pseudo-tested method. And why? It's because there is actually a bug in the test, and there is a fail that is missing here. So that's one of the findings you can have with Descartes. So it allows you to identify which tests are weak. So as I said, we made some experiment with Descartes, and we found pseudo-tested method in every project we tested. So sometimes not a lot, but still there is significant numbers of pseudo-tested methods. That is was very surprising for the developers. So Descartes allows you to test the ability of your test suite to evaluate, to find the bugs in your test suite, and to find the weaknesses. And then we have another tool that is called DSpot. And DSpot allows you to automatically enhance your test suite. So either by generating new assertions that are missing in your test or generating new tests. So DSpot, instead of mutate the source application, we actually mutate the test suite to generate variant of the test and to increase the mutation score, so the ability of your test suite to detect bugs. For example, if we have such kind of original test case that is Java JUnit test, you can have a mutation operator for the test suite that is removing a method call. And so you instrument the code, rerun it, and you can generate new assertion from the new state of the source application, and then generate a new test based on the previous one. So your you can also, using other operator, like changing the values, the constant values, or duplicating a call, this kind of thing. And you can also complete and have a new assertion in your test. So that's what DSpot did. So we run also experiment with DSpot, and we submitted 19 pull requests with tests generated by it to open source project. And so already 13 requests have been accepted. And so there's still one and 5 under discussion. So all those tools are, the idea of those tools is also to integrate them in the CI, because if you are running the tools in your entire source code or entire test suite, it can take some time, I have to say. And so the idea was also to target only in the CI the changes. So the tools are available either as a novel analysis, as a plugin, for example, for Eclipse or Maven, Gradle, and also as a Linux command line. So if you want, the developer can run it on their application or on the test to evaluate them before committing or whatever, or making a pull request. But the idea is also to integrate them in the system, and some of them already did. Some of our partners already did it. And so to run, use Descartes and to identify weaknesses only on changes that are been made, and then to run DSpot only on the weaknesses identified by this. So it's reduced drastically the running time of each tool. So we also made, so we have XWiki that already integrate Descartes in his CI. And also, don't remember, engineering also, you already integrated, yes, several tools. And so the other test we made is to provide the services, those analyses as services in the cloud. So we made a GitHub application, so you can use it like you can use coveralls or Travis in GitHub. And so when you commit or make a pull request, it will run the analysis offline and give you the feedback of the analysis through the GitHub interface. So if you want to know more about everything, we have a GitHub, we have a website. And so we are really expecting feedback from industry, because it's really the way of research to improve their algorithms, their heuristic. There is a lot of things based on genetic algorithm and heuristic, and we need really to have a lot of feedback from real usage. So the contact or either anything of STAMP, the diverse team in area, or the research on the subject Descartes and DSpot are made also jointly with KTH in Sweden. And so thanks. So there is some commit strip, if you know them, that are about the project. We made a lot of dissemination effort thanks to OW2 to this project, and it includes this kind of cool pictures. So thanks.